Algebra 2, 13.3, Part 2 notes. Make sure you have out your unit circle and your trig number 2 packet. Turn to page 3. All right, for the unit circle, we filled this in yesterday. You should have had all the degrees and the radians. If you were not here, there is another video online for how to fill out the circle, so just hop on there when you have a chance. Okay, in your packet, turn to page 3. We're going to fill in just a couple of the blanks that we didn't get to yesterday. So we have the unit circle, which your radius is always 1. So when you are drawing this point, anywhere you draw it, that hypotenuse is always going to be 1 anywhere around your circle. Okay? So if you're trying to figure out the sine theta, you can think of SOHCAHTOA, sine opposite over hypotenuse would be y over 1, which is going to simplify just to be y. So sine is going to always be the y value. Cosine, SOHCAHTOA, ka, adjacent hypotenuse, x over 1, will simplify just to be x. Then tangent theta, there's two ways to see this. So tangent theta, TOA, you can go opposite over adjacent, which is y over x. But notice that that also means that it's going to be the sine value divided by the cosine value, because that's what y and x were. Okay, so the coordinates of any point, since it goes x comma y, are going to be the cosine theta, then the sine theta. All right, let's flip it to page 4 and practice this a little bit. So thinking about which functions are positive. Your ordered pair always goes x and then y. So the x is the cosine and the y is the sine. So in quadrant 1, x and y are both positive. So those are both going to be positive, as well as the tangent is sine divided by cosine. A positive divided by positive is still positive. So in quadrant 1, all functions are positive. Okay, in quadrant 2, notice it goes left and up. So the cosine is now negative, the sine is positive. So both the sine and the cosecant are positive. In quadrant 3, you're going left and down. So the cosine and the sine are both negative. But when we do the tangent, that's going to be sine divided by cosine. So a negative over a negative is going to be a positive. So it's the tangent and the cotangent that are positive in the third quadrant. And in the fourth quadrant, you're going right and down. So the cosine is positive, the sine is negative. So it's going to be the cosine and the secant that are positive in the fourth quadrant. One thing you can remember, if you look at the first initials here, all students take calculus. That will help you remember which ones are the positive functions. All right, so if we want tangent greater than 0, when is tangent positive? We said quadrant 3 and also quadrant 1. So 1 or 3. When is secant negative? So secant goes with the cosine. So cosine will be the x value. When is the x value negative? So when were we going to the left? That is in quadrant 2 or 3. When is the sine positive? That's going to be the y value. So when are you going up? So we're going up in quadrant 2 and up in quadrant 1. So 1 or 2. Finally, this one has kind of two stipulations here. Cosine negative, so we're going left, so it's one of these two. And then, so either 2 or 3, and then cotangent to be positive, which was quadrant 3. So the only one it could be was quadrant 3. All right, let's continue on here. So finding the reference angle and then figuring out what would the cotangent of 315 be. So first, let's go ahead and sketch it out. So if we sketch out 315 degrees, you're now in that fourth quadrant. So we go 180, 270, 315. How much short of 360 is it? You can subtract 360 minus 315 and realize that it's 45 degrees short of 360. So that makes your reference angle. Okay, so then we've got to think of our 45, 45, 90 triangle. What are the side lengths? So we have n, and n squared to 2. So I just let my n be 1. Now, because you're going to the right and down, it's going to make the down one be negative. So we go 1, -1, and then square root of 2. So now cotangent, for cotangent, remember that you're going to do, it's the opposite of tangent. So TOA, opposite over adjacent. So adjacent over opposite. So starting at 45 degrees, adjacent is 1 over opposite, -1, and then we can simplify that to just be -1. Okay, so technically the cotangent of 45 degrees would be +1 up here, but when we're adjusting it to be in the fourth quadrant, it makes it to be -1. All right, let's try the next one. Tangent of 240. So go ahead and draw the picture. Think of where 240 degrees is. All right. Should be over here in the third quadrant. So 240 degrees. Well, how much short of 180 was it? That's going to be our reference angle. So we're always drawing it up to the x-axis or down to the x-axis. So we go 240 minus 180. That makes that reference angle be 60 degrees. All right, so 60 degrees. So now this is our 30, 60, 90 triangle. So I'm going to let my short leg be in, my long leg be square. I'm going to let my short leg be in, which I'm going to let it be 1. My long leg be the square root of 3, and then the hypotenuse would be that 2. Now, when we do this one, figure out which one's negative. So I'm going left, meaning negative, and I'm going down, also negative. So I need to make my -1 part negative and my square root of 3 part negative. Okay, so now I want the tangent. So this one, TOA, so starting at 60, we go opposite over adjacent. Okay, so we're going to go negative square root of 3 over -1. A negative over a negative will simplify to be a positive. Now, if you're using the unit circle to do that one, you would set it up the sine over the cosine, so the y value over the x value, and you could use that keep, change, flip. So you can do it either way. All right, let's try the secant. Secant of 300. So we sketch out 300 degrees. Think about where that would be. Okay, this one is in the fourth quadrant, so we're going to compare it to 360. So how much short of 360 is 300? That would be 60 degrees. So that's going to be your reference triangle. So it's really going to look just like number 9, the reference triangle. Only thing is you're going to the right and down, so the 1 becomes positive, right? Right 1, down square root of -3. So if I want to do secant, secant is the one that goes with the cosine. So we're going to do cosine adjacent hypotenuse. This time I'm going to do hypotenuse adjacent. So if I start at 60 degrees, the hypotenuse would be 2 over the adjacent would be 1. Okay, hypotenuse is always going to be positive. So it's just the x and the y that could be negative. So 2 over 1 just simplifies to be 2. All right, let's try some when they're in radians to start. So if I look at number 11, this one is the cosine of 11 pi over 6. So if you can imagine where 11 pi over 6 is, remember we talked about the whole circle would have been 12 pi over 6, 2 pi. So just back one, 11 pi over 6. Okay, otherwise use that conversion. So we can take that times 180 over pi to get it to a degree. Okay, so if I do that, the pi's cancel. The 180 turns to 30 times 11, and we get 330 degrees. Okay, so now I want the cosine of 330 degrees. So my reference angle here, I can take that 360 minus 30, or minus 330 to get our reference angle to be 30 degrees. There we go. Okay, so then cosine 30, if I start at 30, cosine adjacent hypotenuse, square root of 3 over 2. Notice that it stays positive because I'm going to the right. It's the down part that was negative on this one. Okay, so just square root of 3 over 2. All right, for number 12, cosecant 7 pi over 4. First thing, think about where 7 pi over 4 is. So if you can imagine where it's at, go ahead and sketch it out. Otherwise, convert it to a degree times 180 over pi. All right, times 180 over pi, we could simplify that to be 315 degrees. So from there, we're thinking, what's a 315 degree picture look like? It's going to be down here in the fourth quadrant. And how much short of 360 was it? 45. So 360 minus 315 was 45 degrees. So that's my reference angle. I'm going to the right and down. So the x is positive, the y is negative. Okay, so if I want cosecant, cosecant is the one that goes with sine. So I'm going to do hypotenuse over opposite. So S-O-H, H over O. So then the cosecant of 45, hypotenuse would be square root of 2 over opposite, negative 1. So then we can simplify that, negative square root of 2. All right, sine of 4 pi over 3. Go ahead and sketch that out. Think of that as a degree, or if you can think of it in radians. All right, so if I go times pi over 180 over pi, I should get it to be 240 degrees. So we can think about where is 240 degrees. That would be 240 minus 180 would be 60 degrees. So 60 is going to be your reference angle. Now for this one, we're going left and down. So both of them are negative. Okay, so sine so, opposite over hypotenuse, negative square root of 3 over 2. Okay. All right, go ahead and pause the video and then try these last three, numbers 14, 15, 16. 16 is a little bit different because it's on the x and y axis. So if you need help with that one, I'll go through it in just a minute. So go ahead and pause the video and try those. All right, for number 14, if I do 3 pi over 4, that's 135 degrees. So then tangent opposite over adjacent would just be negative 1. Okay, sine of 7 pi over 6 down here in the third quadrant. So both the x and the y are negative. So sine, so opposite over hypotenuse, negative 1/2. And then the secant pi over 2, if I change that to a degree, that's 90 degrees. So that's going to be the point right on that y-axis. So what would be the secant at that point? Well, what we need to remember is that's the point 0, 1, because it's the unit circle. And then think about your ordered pair. It always goes cosine and then sine. So secant would be 1 over the cosine. Okay, so 1 over cosine 90. Well, at this point, the cosine is 0. So we say 1 over 0, and we're going to get undefined, okay, because we cannot divide by 0. Had it have been the cosecant of 90, then it would be 0 because it'd be 1, because it'd be 1 over 1, okay? But since it was the secant, we cannot divide by 0. All right, so for your assignment, you can look at page 7 and 8 and just see if you can work through some of those. We will continue practicing this more next week. I kind of showed you using the reference triangle to calculate all of these answers, but you could use the unit circle as well. And there is another video posted on Canvas if you would prefer to use the unit circle going through these same notes. All right, we'll see you later. Good job, guys.